Hello, students. We are going to look at Unit 11, Lesson 4, where we are solving one variable rational equations in mathematical context. Our benchmark for this lesson, MA 0.912.AR.8.1, which says, write and solve one variable rational equations. Interpret solutions as viable in terms of the context and identify any extraneous solutions. Here are our learning targets. I can solve one variable rational equations given a mathematical context, and I can determine extraneous solutions. Let's look at some guided instruction. First, here on this slide, we see this is one method of solving these rational equations. The first step says note any value of the variable that would make any denominator 0. Second step, find the least common denominator of all denominators in the equation. The third step, clear the fractions by multiplying both sides of the equation by the LCD, which is our least common denominator. 4, solve the resulting equation. And 5, we're going to do a check. The values that we get for x or any variable we're solving for, we're going to replace it or substitute it back into the original equation. So before we start using that method, let's look at this proportional relationship. We have x over 12 is equal to 33 over 20. So to solve proportional relationships, we can cross multiply and then divide to solve for the letter, the variable, in our problem. So let's show our work. We can cross multiply. We have x is across from the 20, so we can multiply those, which gives us 20x equals, multiply across on the other side, 12 times the 33 let's put the x in parentheses. Okay, so 20 times x is 20x equals 12 times 33 is 396. Now, we already know how to solve for a variable. Here we're multiplying 20 times what gives us 396. So to find what the value of x would be, we would have to divide both sides by the number in front of that x, which is 20. The 20s will cancel. X is going to equal to, so we're dividing 396 divided by 20, which gives us 19.8. So now here we've solved for x, and we got 19.8 for x. Now let's go back and check. In our original, we have x over 12. We're replacing 19.8 for the x. Over 12, and they're saying that should equal to 33 over 20. So if we grabbed our calculator, let's do 19.8 divided by 12. That gives us 1.65. And that should equal to, if we did 33 divided by 20, that also gives us 1.65. And that checks. So looking at this process, we also have another method of solving these rational expressions or equations. So we have the multiplication property of equality. If A equals B, then A times C should equal to B times C. Okay, I'll give you a minute to write this down. Get this in your notes. Okay, 20 seconds. All right, let's move on. All right, so here, how to use the multiplication property of equality to solve. 6 over x plus 3 equals 4 over x minus 3. Include what should be multiplied to both sides. So when we're doing these, we need to first figure out what our common denominators would be. And in this case, x plus 3 times x minus 3 would be our common denominator. So what we're going to do is to take the equation 6 over x plus 3 and we're going to multiply this times what our common denominator is going to be, which we said x plus 3 times x minus 3. We can only use what we have in our denominators. Sorry about that, guys. Let's use the parentheses instead. Okay, that's going to equal to, on the right side, we have the 4 over x minus 3. And same thing, we're multiplying x plus 3 times x minus 3. So now going back to the left side, what can we cancel out? We can cancel out, because this is over 1 on both sides. The x plus 3 on the left side, we can cancel out. What are we left with? We have 6 times x minus 3. That's going to equal to, on the right side, what can we cancel out? We have the x minus 3's we can cancel out. And we're left with 4 times x plus 3. Now we've gotten rid of the fractions. Now left side, let's multiply out. 6 times x gives us the 6x. Let's move down here. Minus 6 times 3, which is 18, equals, on the right side, multiply out. Get rid of the parentheses. 4 times x, which is 4x, plus 4 times 3, which is 12. All right, so now we have 6x minus 18 equals 4x plus 12. Let's solve. Let's take away the 4x on both sides of the equal sign, and we're left with 2x minus 18 is equal to 12. And then add 18 to both sides. Eighteens cancel here, so we have 2x is equal to 30, because 12 plus 18 is 30, and then divide by 2. So our x is equal to 15. So we're going to determine whether the x value is a solution or an extraneous solution using substitution. So to determine, we would have to replace that value of x into the original equation on both sides of the equal sign. So over to the left here, we're going to do that. We have 6 over 15 plus 3. Is that going to equal to 4 over 15 minus 3? So let's work it out. 6 over 15 plus 3 is 18, so 6 over 18. Does that equal to 4 over 15 minus 3? 12. If we simplify both fractions, the first one we divide by 6, that gives us 1/3, equals 4 over 12, reduces, simplifies to 1/3. 1/3 does equal to 1/3, so this is a solution. So x is 15. Okay, I'll give you a couple of seconds to go ahead and write this down. So the only time it is an extraneous solution, it's when x does not equal to that number, when this does not check. Okay, 5 more seconds. All right, let's move on. All right, here's another example. Let's consider this rational equation and solve for x. So first, we need to find a common denominator and multiply all fractions with that common denominator. So as you can see, we have 5 over 8 minus 3 over 5 equals x over 10. So our common denominator between 8, 5, and 10 would be 40, which we have here. So we're multiplying the entire expression by 40. So we first start out with the 5 over 8. So 40 times 5 over 8. Let's do it over here to the left. So we have 40 times let me erase this real quick. Make sure it's written properly so you are able to see it. So let's do 40 times the 5 over 8. So I know I can cross cancel 40 and 8. 8 goes into 40 5 times. And 8 goes into 8 once. So now what's remaining? We have 5 times 5, which is the 25 we have here. Okay, minus. We do the same, the 40 times 3 over 5. Put the 40 over 1. So I can cross cancel again. 5 goes into 5 once. 5 goes into 40 8 times. And then multiply what's remaining. 8 times 3 is 24. So let's use a different color here. And then the x over 10, we do 40 times x over 10. I wanted to do the dot. Let's erase this one right quick. All right, so 40 over 1. So cross cancel again. We can divide by 10. 10 divided by 10, it's 1. And 10 divided by 4, 10 into 40, 4 times. So multiply what's remaining, where we have 4 times x, which is 4x. So we've simplified it where we got rid of our fractions. So now we have 25 minus 24, which is 1. And that's going to equal to 4x. So 1 is equal to 4x. To solve for x, divide both sides by the number in front of the x, which will give us 1 over 4 is equal to x. Here we're solving for x. So as you can see in letter B, it says to solve, we can divide by 4 to find the value of x. Okay, let's move on. Here's another example. Let's consider this rational equation. We have x plus 3 over x minus 3. That's going to equal to 12 over 3. So first, to start, we can cross multiply in a proportional relationship and then follow the rules for solving equations. So when we cross multiply, we're multiplying across from each other. X plus 3 times the 3, which we see here. And then on the other side equals to 12 times x minus 3, which we see right here. So now we've gotten rid of the fractions. Starting on the left side, let's multiply out. So we're going to take the 3 outside and multiply to that x, gives us the 3x, plus 3 times 3, which is 9, equals, do the same on the right side. Let's get rid of this. Multiply 12 times x, which gives us 12x, minus 12 times 3, which is 36. And from there, we use the rules for solving equations. So I like to take the smaller of the variable terms, where we have 3x is our smallest. So I'm going to do the opposite to that, which gives us a negative 3x. And I'm also going to get rid of that 9, that positive 9. So I would have to minus 9. So doing that to both sides of the equation, in this row right here, we will have 0 equals 9x minus 45. 0 equals 9x minus 45. So to get the variable by itself, we're going to add 45 to both sides. So this is how we have 45 is equal to 9x, and to solve for x, divide by 9 on both sides. So 5 is equal to x. So for letter B, as you can see, check the value of x. So we're replacing in our original equation, wherever x is, the value we just found for x. So we replaced 5 in the numerator for x, 5 plus 3 over 5 minus 3. That should equal to 12 over 4. Oh, I'm sorry, 12 over 3. So 5 plus 3 is 8 over 5 minus 3, which is 2, equals 12 over 3. 8 over 2 is equal to 4, and 12 over 3 is also equal to 4. So this checks. This is a solution. X equals 5 is a solution for this example. After copying this slide, give you a few seconds to go ahead and get everything down. You can always pause the video so you're able to understand what it is that you need for the examples given. All right, let's move on. These seem pretty complicated, but they aren't. So it's just a matter of taking it step by step. So in this example, two students were solving the equation. We have 3 over x minus 1 minus 2 over x minus 4 equals negative 6 over x squared minus 5x plus 4. So we can determine what our common denominator is. Factor the x squared minus 5x plus 4. So remember, factors are 4. When you multiply, you get 4, but when you add them, you get 5. In this case, this would be, when it's factored, x minus 1 times x minus 4. As you notice on the left side, you have the same denominators as what we just factored over on the right side. So that would be our common denominator. So look at Danielle's work. She multiplied both sides by x minus 4 times x minus 1. There and here. And doing so, she took each fraction so she can get rid of them, get rid of the fractions and see what can be canceled out. So x minus 1 cancels out with x minus 1, and what was left is 3 times x minus 4. Minus, do the same with the 2 over x minus 4. In this case, we can cancel out, let's get rid of this one here, doing it for the next set. So we can cancel out the x minus 4 here, and we have left 2 times x minus 1, which is what she has here. Over on the right side, as you can see, the x minus 4s can cancel, and the x minus 1s will also cancel. All of these are equal to 1. So all we have remaining is the negative 6, which is what we have here. Look at Bryson. Has the same example, and what he did was to find the common denominator just the same and place them under each fraction. So in the first, x minus 1, what is missing would be the x minus 4, which is what he added here. For the 2 over x minus 4, what's missing would be the x minus 1. And then to the right, it has both already, so he didn't have to do anything. And from there, because we have the same denominators, here we multiply out 3 times x minus 4 minus 2 times x minus 1 equals to negative 6. So now, Daniela found the least common denominator, as said before, and used the multiplication property of equality. Bryson rewrote the rational expressions by finding a common denominator and the second numerator is equal. So look at the two different methods. You can always go back, look at the two different methods shown by Daniela and Bryson. So now you find the solution to this example. Use one of those methods given. So we have I'm using Daniela's 3 parentheses x minus 4 minus 2 parentheses x minus 1 equals to negative 6. Let's multiply out. 3 times x is 3x, minus 3 times 4, which is 12, minus 2 times x, which is 2x, and then minus 2 times minus 1 is plus 2, equals to negative 6. Combine like terms, we have 3x minus 2x, which is 1x, and negative 12 plus 2, which is negative 10, equals to negative 6. Add 10 to both sides. X is equal to 4. Now the challenge I have for you, go back in and replace the 4 in for all the x's in this example. Check to see if there are any extraneous solutions for this example. Thank you so much for listening. I hope this was clear and understandable. Have a good day.